Okay, let's do this last example here. In the Cash 5 lottery in Connecticut, a player pays $1 for a single ticket with 5 numbers. 5 balls numbered 1 through 35 are randomly chosen from a bin without replacement. If all 5 numbers on a player's ticket match the 5 chosen, the player wins $100,000. The probability of this occurring is 1 over 324,632. If 4 numbers match, the player wins $300, and that occurs with a probability of 1 over 2,164. If 3 numbers match, the player wins $10, which occurs with a probability of 1 over 75. Compute and interpret the expected value of the game from the player's point of view. So again, we have X being the profit for the player, and we have P of X being the probability of getting each result. So if all 5 numbers are correct, the player wins $100,000, but remember they paid $1 for the ticket. So their profit is only 99,999. Okay, if they get 4 numbers right, they get $300, but again, they paid $1 for a ticket, so their profit is $299. If they get 3 numbers right, they win $10, but they paid $1 for a ticket, so their profit is $9. And remember, there's another outcome where they don't win anything, which means they just lose the $1 they paid for the ticket. So we have the probabilities. Winning the big prize happens 1 out of 324,632. Winning with 4 numbers happens 1 out of 2,164. Winning with 3 numbers is 1 out of 75. How do we figure out the probability of losing our money? Well, this is another complement problem, so it's going to be 1 minus the other 3 probabilities. So 1 over 75 minus 1 over 2164 minus 1 over 324,632. Now we will put this again in one-var stats with list as L1 and the frequency list as L2. And we're going to put the X's in L1 and the PX's in L2. And I'm going to show you how to enter all this in the calculator so that you don't spend a lot of time and having to write numbers down, etc., etc. So let's move this where I can see. Well, I guess I can't. We'll just have to move it around as we go. Okay, so let's go to Stat and enter so we can get to our lists, and highlight the list names and clear if you need to. Okay, so we have 99999 for one entry. The next one is 299. The next one is just 9. And the last possibility is we lose $1, so -1. In L2, we're going to have 1 divided by 324,632. Now, don't worry about this e to the -6. That's just scientific notation. Also, don't worry about the fact that the calculator is only displaying 3.1 because that's just, it's just displaying that. But if you click on it, then the full number should be there. Oh, sorry, if I highlight it. Yes, see, if I highlight it, the full number's there. It keeps going, so it'll have that scientific notation. The next entry is 1 over 2164. And then 1 over 75. And for this last one, we can just type 1 minus 1 over 324,632 minus 1 over 2164 minus 1 over 75. And you see that the probability of us losing $1 is 98.62%. This right here is why I will never buy a lottery ticket. So now that we have our data in, we can quit to our home screen, then hit Stat, go to Calc, 1var Stats. We already have L1 and L2, so we hit Calculate. Remember, the expected value is the mean, and we're talking about money here, so we should round to 2 decimal places, so 0.42. But it's negative. Don't miss the negative sign right there. It's easy to do. So, excuse me, our expected value is negative 42 cents. So what does that mean? It means if we buy a large number of tickets, we expect to lose 42 cents on average per ticket. Now remember again, that's if we buy a large number of tickets. Obviously, if we only buy 1 ticket and we don't win, we've lost $1. So this is averaging out over hundreds and thousands of tickets. Well, that concludes section 6.1 on discrete probability distributions. In chapter 7, which we'll start next, we'll talk about continuous probability distributions, specifically the normal distribution.